In this podcast, we're again going to be looking at changing from logarithmic to exponential form and from exponential to logarithmic form. But this time we're going to do it by just manipulating the formulas a little bit. I call it a structural approach to doing the problem. I want to begin by talking about the structure of a log equation and the structure of an exponential equation. When you look up here at the top part at this logarithmic equation, I want you to note the structure here, that the y, the equal sign, the word log, and the x all are on the same line. There's only one thing that's not on that same line, and that's the base a, and it's below and right after the word log. You must maintain that structure. The only thing that goes below that line is the base a. And if a is the base, it must be below that line. Otherwise, you will be writing a equation that means something different than what you wanted it to mean, and it will be wrong. Again, look at the exponential form. In this case, the exponential base is not below the line, it's on the line. Contrast that with the logarithmic base, which is placed below the line. The exponential base is on the line with the equal sign and with the y. And the x, the exponent, is above. So those are the two forms that we have to maintain as we go through these problems. Now, the basic idea is this. If I want to go to logarithmic form, I'm going to switch the numbers that are not the base. In other words, the 1/16 is going to move over here, the -2 is going to move over here, and the exponential base is going to stay the same, and it's going to be the only thing below the line, and then I'm just going to add the word log in front. So since 4 is the base, I'm going to start off log, and since 4 is the base, it's going to go below the line, down like that, log 4. Now, the next thing I want to do is I want to switch the numbers 1/16 and -2. The 1/16 will come over by the 4, so this will be 1/16 right here. And the -2 will move to the other side where the 1/16 was, and that's how we change from exponential to logarithmic form. If you watch the podcast on the verbal approach, this would say the exponent of 4 that gives you 1/16 is -2, or another way is to read it from right to left. -2 is the exponent of 4. But all you have to do this is drop the base down, write the word log in front of it, and then interchange the 1/16 and the 2. Here we do the same thing. This time though the base is e. So I'm not going to write log base e because we have a special symbol for log base e. We just write ln. So that way we won't be showing any base. So I'll just write ln, that means log base e, and then I have to switch the 0 and the 1. So the 1 will come over here by the log base e, and the 0 will go to the other side. Let's go to the next one. This time the base is 10, so if I'm going to change this to logarithmic form, I'm going to write log base 10, but when the base is 10, you can just leave it blank. Leaving it blank automatically means that the base is 10. Again, I'm going to switch the 2y with the x plus 4. So the 2y is going to come over here with the log, and the x plus 4 is going to move to the other side. And finally, in this one, we have 4 is the base. I'm changing it to logarithmic, so I'm going to go log with a base 4 down below. I'm going to switch the 3 and the 64, so the 64 comes over with the log, and the 3 goes to the other side. And I have changed those from exponential to logarithmic form. Now let's take a look at the same problems worked going from logarithmic to exponential form. In this case, again, we're going to switch the upper numbers we're going to maintain the base. In this case, the base is invisible. The base is e because we're doing a natural log. So I'm going to have a base e, and if you look at the exponential form, the base is on the same line with the equal sign and the y. So I'm going to have the base on the same side with the equal sign, and I'm going to be switching this. So this is going to say the e to the x is going to go to the other side, and the x is going to become the exponent of e. So I'm just going to get e to the x equals e to the x. Kind of hard to dispute that. Let's go on to the next one. This time the exponential base is 4. It'll be on the same line as the equal sign. The 3 and the 64 will change places. So the 64 will come over here. The 3 will take its place above the 4. In the next problem, we have another one of those invisible base problems. The base here is 10. So I've kind of made like a ghost 10 there. So we've got an invisible base of 10. So I'm going to put 10 on the same line as the equal sign. Then I'm going to switch the 0 and the 1. So the 1 is going to come over to this side where the 0 was, and see how the 1 was above the 10. Now the 0 is going to go above the 10. So I get 10 to the 0 equals 1. Well, anything to the 0 is 1, so that certainly makes sense. And now let's go to the last one. Here the base is b, so I'm going to, whoops, that's not a logarithm. Let me put a log in there because we're supposed to be doing logarithms. We'll say the log b of b equals 1. And now we want to change that to the exponential form. So the base is going to be b. I want to switch the 1 and the b, so that is this 1 and this b. I want to switch those, so this b will go over to the right, and where the b was above the b, now the 1 will be above the b. We get b to the 1 equals b, and that is correct. And there's kind of a structural way to change from logarithmic to exponential form. Now if you have to evaluate something in this method, like the exponent of 3 that gives you 9, for instance, you could just write it this way. You could say y is the exponent of 3 that gives you 9, and then do your structural change. 3 is the base as you change it to an exponential. The 9 and the y will change places, so you get 3 to the y equals 9, and 3 squared equals 9, so that tells you y has to equal 2. So log 3 of 9 is 2. And that completes the podcast on changing from exponential to logarithmic form.